everybody. Today we're going to start our unit on trig equations. First thing we want to know is just to determine if a value is actually a solution to the equation. So we're looking at the sine of theta being square root of 3 or 2, and I want to know, is 4 pi over 3 a solution to that? So at 4 pi over 3, we're sitting over here in quadrant 3, and you say to yourself, what is the sign of that value? Well, the sign here would be negative 1/2. So the answer here would be no, not a solution. For problem B, you need to isolate the trig function first. Actually, I take that back. You really don't. You can just plug on in here. So at 11 pi over 3, we go 3, 6, 9, 10, 11. That puts us over here. I want to know what is the sign value for that coordinate there, and that would be negative square root of 3 over 2. We plug that value in for sine. These guys cancel out. We get negative square root of 3 plus square root of 3, which does come to 0. So that is our solution. So our answer here would be yes. Okay, so let's take a look at our next two problems. At pi over 6, we're sitting over here. Your coordinate would be square root of 3 over 2, 1/2. I want to know, is the cosine of theta equal to 1/2? The answer here is no. It would be square root of 3 over 2. Lastly, 7 pi over 4 would put us over here. These are our coordinates. Tangent would be y over x, which would get us negative 1. So our answer here would be yes. Okay, so now it's time to actually start solving some of these. We just have some tips in the box here for us to look at. We do want to isolate the trig function. We can do this by combining like terms, extracting square roots, identifying the angles, and then write equations for general solutions or specific. I'm going to start with the general solution. So I'm looking at problem number 2, and I say, okay, what angle theta is going to give us negative 1/2? So the first thing I want you to do is give me any angle that will yield to negative 1/2 anywhere on one rotation of the unit circle. So this is different than finding inverse angles, okay? So what angles would give us negative 1/2? The answer to that would be 7 pi over 6 and also 11 pi over 6. Those are specific equations. They're asking us for the general solutions. So when I look at this here, 7 pi over 6 would be in quadrant 3, 11 pi over 6 would be there in quadrant 4. Since I can't get here with a half or a quarter rotation, I'm going to have to add a full rotation of a circle to get back where I want here. And we do this by adding 2 pi k. 2 pi is a rotation around the circle, a full rotation. K is going to stand for any integer number, saying we can go around once. From here, I could go around once, twice, 3 times, 4 times, an infinite number of times, wind up with the same terminal side. We'll do the same for 11 pi over 6, adding the 2 pi k, and that's what's going to get us our general solution. All right, so for B, we're looking to see what angle is going to yield root 3 over 3. For that here, our two angles would be pi over 6 and 7 pi over 6. Now, if you look at these two angles here, pi over 6 here and 7 pi over 6 here, they're exactly a half a rotation away. So we can actually write this as just one single solution of pi over 6 plus pi k, pi being a half rotation. So if I add pi, I come here, another pi and back, 3 pi's I'm here, 4 pi's I'm there. That's enough to encompass both of these answers for that solution. For the secant, I think it's easier to remember that the secant is 1 over cosine, or cosine is the reciprocal. So we can change this to say the cosine of theta is equal to negative root 3 over 2. Which angles are going to get us negative root 3 over 2 for cosine? That'd be 5 pi over 6 and 7 pi over 6. Since these guys are not a half rotation like the tangent one, we will have to write them separately, adding on the 2 pi k. So 5 pi over 6 plus 2 pi k, and then 7 pi over 6 plus 2 pi k, and that would be the two solutions there. All right, so let's solve a couple of equations. Flipping our papers over. What you want to do first is isolate your trig function. So first I'm going to subtract 4 over. And then I'm going to divide by 4. So I have the tangent of theta is equal to negative 1. We are answering these questions here within a certain interval. So we're not looking for general solutions, just which angles within one rotation of the circle. What angles would get us negative 1? For tangent, that would be 3 pi over 4 and 7 pi over 4, and those would be the two solutions within the interval of 0 to 2 pi. If I look at problem B is already factored for me. So since that's a factor, so I'm just going to put each piece equal to 0. And also cosecant theta would be equal to negative 2. So where is tangent 0? Remember, tangent's y over x. So that would be at 0, and pi would be 2 of our solutions. If the cosecant of theta is equal to negative 2, then the sine of theta is going to equal negative 1/2. Where is sine equal to negative 1/2? That would be at 7 pi over 6 and 11 pi over 6. So B has 4 solutions that would work for those equations. Now if you look at C is not as a set of factors. We're going to have to factor that first. So the first thing we're going to do is subtract the 1 over, just like we were solving a quadratic equation. Have it set equal to 0. We're going to factor. Our only choices for 2 cosine squared x, or 2 cosine x and cosine x. Our only choices for 1 are 1 and 1. We want the O and the I of the FOIL to be positive, so we get a plus here and a minus here. Once we're factored, we set each piece equal to 0 to solve. So here, cosine x would equal 1/2. Cosine x here would equal negative 1. Where is the cosine of x equal to positive 1/2? That is at pi over 3 and also 5 pi over 3. And where is cosine x equal to negative 1? That would be at pi. Okay, let's take a look at D. See what we get here. This is also factorable. So we get 2 cosine squared theta, cosine squared theta. And then we're going to have 1, 1. They both wind up being negatives. Setting this guy equal to 0, I get cosine squared theta is equal to positive 1/2. Now I'm not interested in cosine squared, I want just cosine, so I'm going to need to take the square root on both sides. Please remember, when taking the square root, you need to get both the plus and minus answer, 1 over root 2. So this guy's going to wind up being plus minus square root of 2 over 2 once rationalized. So where is cosine of theta equal to plus and minus root 2 over 2? That's going to be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So quite a few answers there. I also have over here cosine squared theta is equal to 1. When I take the square root, It's also going to be plus minus 1. So where is cosine equal to 1 and negative 1? That would be at 0 and pi as well. So this guy had 6 solutions. All right, so those are kind of your basic problems. We do get into situations where we're looking for multiple angles in here. So first thing I'm going to do when solving this is let mu equal 3 theta. So I'm going to take out the 3 theta, substitute it with mu. All right, so where is mu equal to square root of 2 over 2? So, and it's positive. So we're looking at pi over 4 and 7 pi over 4. Now I'm not actually, that's what mu's equal, but mu's equal to 3 theta. So I have for my first solution, mu's equal to pi over 4. I'm going to put the general solution on there to help me to come up with all the answers that are going to work here. I'm going to take out the mu and substitute it with 3 theta. And to isolate theta, I would have to divide everything through by 3. Okay, that changes the general solution as well. So I'm going to just start adding multiples of k to make it through one rotation without going over. So if k was equal to 0, and I put a 0 here, this would all drop. We get the angle pi over 12. If k is equal to 1, our solution would be pi over 12 plus 2 pi over 3. With our common denominators, that would get us 9 pi over 12, which would reduce to 3 pi over 4. And then I'm going to say, I can keep going, what happens when k is equal to 2. So that's going to get us pi over 12 plus 4 pi over 3. And that gets us 17 pi over 12. I know I can stop here because if I added 6 pi over 3, I would make it past one full rotation on the circle. So these are the 3 solutions yielding from pi over 4. We do need to do the same thing for 7 pi over 4. So mu is equal to 7 pi over 4. Add the general solution to help you get your final answers. But this is really 3 theta. And dividing through by 3, I know theta is equal to 7 pi over 12 plus 2 pi over 3k. And again, we start just letting k equal 0, then 1, then 2, and we stop it once we go past a full rotation. K is equal to 0, we get a solution of 7 pi over 12. When k is equal to 1, we add 2 pi over 3. With our common denominators, that would get us 15 pi over 12, and that would reduce to 5 pi over 4. And lastly, when k is equal to 2, we get 7 pi over 12 plus 4 pi over 3, yielding us 23 pi over 12. So there are the 6 solutions for this problem here. Okay, we've got one more problem to solve for our notes today. And that problem is right here. We're going to kind of work the same way. I'm going to let mu equal theta minus pi. So now I have 4 cosine squared mu minus 1 is equal to 0. Cosine squared mu would equal 1/4. Taking the square root of both sides, I get plus and minus 1/2. So where is cosine equal to plus and minus 1/2? That is at pi over 3, 2 pi over 3, 4 pi over 3, and lastly 5 pi over 3. We're going to do the same thing. Remember, mu is equal to theta minus pi. So theta minus pi is going to equal pi over 3. If I add the pi over, I wind up with 4 pi over 3. If theta minus pi is equal to 2 pi over 3, adding the pi over there, that's going to get me an answer of theta being equal to 5 pi over 3. I'll do the same thing for the next two solutions. Theta minus pi is equal to 4 pi over 3. Adding that over gives me another theta of pi over 3. And then lastly, theta minus pi is equal to 5 pi over 3. Adding theta over, adding pi over, and we get theta here to be 2 pi over 3, which wound up being all the same solutions as over here, but you do need to go through the process. That made one full rotation around the circle, so there would be no other solutions. All right, that's it for today. We'll pick up with another section on trig equations next lesson.